Hey everyone, how goes it? Welcome back to Computer Science 145. Today, we're going to go over some more basic computation. In a previous lecture, we focused mostly on primitive types and mathematical operations associated with it. Today, we're going to focus on class types by looking at several various common class types that we can use. Now, the first thing, the class type is not like a primitive type. Primitive types are just simple numbers or characters. Class types group together lots of data with functionality that we call methods. Now, to best understand this, classes create instances that we call objects. Sometimes these terms are used interchangeably, but one leads to the other. You create a class, a classification of objects. Now, it's also important to keep in mind that class types are separated by their references and their contents. The way that we can think of this is the reference is the memory address that points to the object's contents in memory. The reference is the only value that's stored inside of an identifier. The contents is what contains the data and the functionality. So we can see this right here. If we had this object identifier, what's held in its contents isn't the object, it's just a reference to memory address 28. From there, this object might have some data 1 or data 2, and it might have all these other methods that's defined inside of memory. The big thing to keep in mind is the identifier only holds a memory address for class types. Now, once again, classes create instances that we call objects. Objects must be constructed before they are ever used. As we've described before, Java assumes default values. In this case, the default value for an object is null. Null means nothing. It means the object currently does not exist inside the computer. We cannot use an object that doesn't exist. And for the most part, the reserved word new is used to construct the instances of most class types. But as we're going to see, we don't usually use them for strings. Now, methods provide functionality for an object. It's what the object does. Think of it in these terms. The object can be considered a noun, and the methods are considered the verbs. We are communicating with the machines, so it's good to know what are nouns and what are verbs. Now, whenever we're calling methods, what we're doing is reusing code. A method has functional code written in it. When we call a method, what we're doing is running that code. Now, the way that we can call these methods is by using the identifier, the dot, followed by the method name and the arguments, and we can see that syntax over here. Now, looking more specifically at a class type, let's take a look at strings. Now, once again, this is a class type. The data in a string can be considered as an array of characters. The methods, again, are the built-in functionality that do operations upon the string. Strings are denoted by using double quotes. Single characters, on the other hand, use single quotes. We use strings to group together single characters into words and phrases. And this is very useful for outputting and formatting data, and also useful for inputting data such as words or sentences. As we've seen in the past, the way that we declare a string is just like other variables. You start out with the type, give it an identifier, then what we do is we use the identifier and assign it to some sort of string value that's denoted by the double quotes. The data inside of a string is called an array. We're going to get into arrays later on. However, a string is more specific, an array of characters. And this means that it is a contiguous collection of characters in memory. It's useful to know this because we are able to access individual characters by using what's called an index. All arrays have indices that correspond directly to these values. Indices will always start from index 0 and go up until the length -1. So if we have this example string right here, we can view the string as this kind of array. Up here are all the indices. So as we can see, we have 1, 2, 3, 4, 5, 6, 7 characters. And so it starts at index 0 and goes to 7 minus 1, 6. Individually, index 0 has A, index 1 has B, C, D, E, F, and G. A string is just a collection of characters, and we can access individual ones by understanding what its index is. Now, as strings are class types, they have methods, and here are some very common ones. The first one that we have seen before is the plus operator. Now, we've seen the plus operator in relation to primitive types, but we've also seen it with strings. What this does is it concatenates a value into the string. It's not quite the same thing as the mathematical plus. It is appending information to a string. Now, just besides operators, some useful methods that we use a lot are length, char at some index, substring starting from some index, substring starting from some index and ending at some index, to uppercase to lowercase, and split using a regular expression. We can see an example over here where we create this string ABCDEFG. Now, if we call system.out.println, if we call this string.char at index 0, this is the first character. This is why our console would print out A. Now we also see that what we have here is we set the string 2 equal to this str.substring starting from index 2 and going to 5 exclusively. So if we start at index 0, 1, 2, and then we go into 2, 3, 4, and not 5, then our substring, our smaller string, is just C, D, and E, which prints out right here. Besides just saying what these useful methods are, how can we look up methods that are built into strings? One thing that we can do is look at the Java Development Kit, the JDK. This gives you all of the class types with every one of the associated methods with it. Now, this right here is only a small sample of some of the methods that we can use inside of strings with a few different examples. So how we can read this is the method name and these are the arguments. So as we saw before, char at. This returns the character at the index in the string, and index numbers begin at 0. So in this case, if our string S is always Java and we call char at index 2, 0, 1, 2, this would assign the value V. Now let's look down a little bit because characters are not the only return type. Methods sometimes return values, and this entire statement right here just becomes whatever this return type is. So for instance, if we go down here, we see equals. So we would take a string dot equals another string, and this returns a Boolean. So true or false. If we assume once again our S is equal to Java and we call S dot equals the same thing, then of course B is going to be equal to true. In addition to that, we also have equals ignore case, which does the same thing as equals, but it just ignores case. Index of. This returns a type integer, and basically it is the index of the first instance of whatever this argument is. So if we pass in VA, the index of this starts at 0, 1, 2. As mentioned before, we also have this method .length. This gives you the number of characters that are found inside of this string. This can be very useful to process information. From there to lowercase to uppercase, which respectively lowercases or uppercases all the characters in a string. This can be particularly useful if you just want to simply ignore the case in any string. Now, scooting down a little further, we also see the methods substring and substring. Now, these have the exact same name, but they have different arguments. Let's read this one. Substring with a start. This returns a new string having the same characters as the substring that begins at the start through the end of the string. Index numbers always begin at 0. Okay, let's see what's the difference with this other one. This returns a new string having the same characters as the substring that begins at the start through but not including the character at the index n. It's important to note that the start index is considered inclusive. It includes that character in the substring. However, the end index is exclusive. It does not include that character. It is really good programming practice to look through the various libraries that we can use. Strings are so very common that it is very useful to understand the methods that we can use to operate upon these strings. So now let's see a string inside of memory and see what happens here. If we take this example, the first statement simply just declares this type string. Just like every other declaration of a variable, this does the same thing. But it's important to note that the default value of an object is null. Now what we need to do is assign the value ABCD to this string. Before we can do that, we first have to construct this character array ABCD. As we have 4 characters, as you can see here, we have 1, 2, 3, 4 characters. And then it individually assigns ABCD to each one of these indices. Now the last thing that happens is this str is assigned the value of 64. What is held inside the identifier is just a memory address that points to the contents of this string. For argument's sake, we also omitted all the methods that are built into the strings as well. Always remember, when it comes to class types, which include strings, they are always separated by a memory address, the reference, and its contents. Now, to best understand strings, we also have to talk about a very specific and special type of character called escape characters. Now, these are mostly used to better format strings. And even though there are 2 individual characters, they're considered one single character. They always start with a backslash. So for instance, if we wanted to put a quote inside of a string, then we have to use backslash quote. Same thing for single quote. If we wanted to put a literal backslash, then we have to use 2 of them. Now /n indicates a new line, which means it goes to the beginning of the next line after that's called. /r is the carriage return, which does something fairly similar. And also /t adds a tab, and this adds space until we reach the next tab stop. So if we were to write this string right here, then notice what gets printed out. First is hello, and then we have the escape character /n, which jumps to the next line. Then we have the literal quote, and then another literal quote, which puts quotes around world. Finally, we have to enclose this string by having the closing quotes. Scanner is another common class type. Now, as we've seen before, these are used to scan or read various things. The standard system input, system.in, strings, files, network traffic. Scanner can scan a lot of things. Now, before we can use the scanner, we have to import it from Java util by always putting the statement import javautil.scanner. This allows us to use the type scanner to create an object. Now, just like before, when we use it, it has to be both declared and constructed. As we can see right here, declaring a scanner simply starts with the type followed by the identifier. Constructing a scanner relies on the reserved word new, which now this will dynamically allocate a new instance, an object, of this type scanner with this name. So just like we've used before, we create a new type of scanner that we call keyboard, and then we construct it by new scanner and tie it together with system.in. Now, once the scanner has been declared and constructed, it can be used by calling its various methods. Now, to best understand this, Scanner uses what's called delimiters. Delimiters are used to separate information by using special characters. Now, when we set up a scanner, it's assumed that all the delimiters are any kind of space unless that is otherwise declared. Now, there are multiple different types of spaces. You have single spaces, you have multiple spaces, you have inlines or carriage returns, and you also have tabs. No matter what, each one of those is considered a delimiter, and it can be used to separate out information. Now, looking over here at this example, we construct a new scanner called keyboard here. Then we declare a variable string and call it name, and then we assign this to keyboard.nextLine. If we look what's in the console here, imagine that I type JJ and then press enter. When I press enter, that adds a new line, which is a delimiter. So this statement right here is going to capture everything up until that new line, so the name just simply becomes JJ. Now the next statement, we declare an integer I and assign it to keyboard.nextInt. Now imagine if I pressed 6, 4, and then enter. So what this is going to do is read everything that is an integer up until that first delimiter. So in this case, when I hit enter, that adds that end line, and so it becomes 64/n, but this keyboard.nextInt only captures the 64, so I just becomes 64. Now you'll notice this keyboard.nextLine that we call the useful fix-up. The reason why it's a good idea to follow up a nextInt or a next double with this keyboard.nextLine is understanding what is actually in this console. When I pressed 6, 4 and enter, it added that inline right there. However, the scanner only captures the 64, and what's left over is that end line. When we call keyboard.nextLine, the scanner consumes that inline for us. And the same thing happens here when we declare a new type double, call it J, and we call keyboard.nextDouble. If I were to enter 3.14 and enter, that adds that end line, but the double reads everything up until that delimiter, that end line. When we call keyboard.nextLine, it consumes that end line. That way we don't have any potential logic errors. From there, we use the standard system output, called println, and we concatenate together the string name with a space, the value of I with a space, and the value of j, and so we get this output. Some of the most useful scanner methods are next, nextLine, nextInt, nextDouble, and nextBoolean. Next returns a string value up to but not including the first delimited character. So this basically means it captures everything until it reaches a space or an end line. But it does not include that end line. NextLine, on the other hand, returns a string value up until but not including the line terminator. So in other words, that /n. NextInt returns the first instance of an integer value, and all other characters and delimiters are ignored. NextDouble returns the instance of a double value, and all other characters and delimiters are ignored. And nextBoolean does about the same thing. It returns the first instance of a Boolean value, and all other characters and delimiters are ignored. Another type of useful class is called a wrapper class. These classes wrap around or provide functionality to primitive types. These can be very useful to, for instance, convert a string into a primitive type. Some of the most commonly used ones is like integer.parseInt, which will basically convert that string argument into an integer value, double.parseDouble, that converts a string into a double, and boolean.parseBoolean, that converts a string into a boolean. So as we can see here, this value 256, this is a string. We can't do any mathematical operations on a string. It has to be a number. So what we do next is we call integer.parseInt, which converts the string 256 into the integer value 256. Then we multiply 256 by 2 and reassign it, which ends up being the value of 512 that's printed out there. With all of this discussion about class types, let's take a look at an example that uses some of these. Now, as you can see here, we've already set up our project. Now, our problem is this. We are going to imagine that we're creating a multiplayer network game. And as we know, we have to send information to all the players. Now, this information, for argument's sake, is going to be sent as a string. What we need to do is take that string and break it apart into its individual components. Now, the individual components are going to be the player's name, followed by the player's ID, followed by an X position, Y position, and Z position. Each one of those properties is going to be separated by a space. Now, let's go ahead and start this. We're going to go ahead and create a class, and we're going to call this one the player parser. And we're also going to include our main method, our entry point. It's always important to start every source file by writing your name. Now, we're not actually going to perform any kind of network operations. We're just going to simulate this through the console, but we need a way to provide user input. As we know, we're going to use that scanner. But before we can do that, we have to import java.util.scanner. That way we can use the type scanner. From here, we're now going to use the type scanner. So here's our type scanner. We're going to name its identifier keyboard and assign that to new scanner, passing in system.in as our argument. That way we can read in the information from the console. In a minute, we're going to prompt the user, but before we do that, I'm going to add a comment that goes over the structure of these strings, what we are assuming to be true. Once again, I'm going to use my angle brackets, and so the first thing is going to be the name. That is going to be separated. That is going to be delimited by a space. That is followed by the player's ID. That's separated by a space. Then we have an X, a Y, and a Z position that is then concluded by an end line. These are how the strings are going to be formatted. And if we're going to be working with this, we need to understand the formatting of the string. This is essential to solving the problem. How is the information separated? Is it by a special character? Is it by a certain number of characters? But in this case, what we're using is simply a space. Next, we're going to go ahead and prompt the user. Using the standard system output, we declare enter the player's name, followed by their model ID, an int, and an XYZ position of all type doubles. Now we need to declare a variable that's going to be of type string, and we're just going to call it input. Now we need to assign this to keyboard. So we're going to use the scanner to capture something. Now, as we know, this starts here and ends at this end line. So it makes sense to use keyboard dot next line. So this would capture everything starting from here up until but not including that end line. Now we're going to be doing some work on this input, and what I'm going to do is make a copy of this input to do work on it. So I'm going to declare another string, and I'm going to call this the copy input and assign it to our input. The next thing I need to do is separate this information out until they're individual components. So we know this name is going to be a string, and it's separated from everything else by this space right here. So what we need to do is find the index of this first space. we're going to go ahead and declare an int working index. And we need to assign this to something. We need to use our copy input and find this first space, the index of that first space. So I know that class types have methods, and this is functionality. So if I do copy input, and I remember just for a second some of the methods that are built into strings, what I can do is call dot index of the string space. This will give me the first index of this space. Now, once I have the index of this space, I've got to copy everything from the beginning up until that space. In other words, I need to make a smaller string. Remembering what I know about strings, there's a method called substring which will give me a smaller string. So now, if I take this string name and assign that to the copy input dot substring. Now, we need to start from index 0 because all indices start at 0. Now, this needs to go up until this space, which is excellent because working index indicates that. This was the index of this space. We want everything before that, which is done right here. So now we are done with this part of our string. We really don't need this anymore because we've already extracted the data that we needed. So what we can do is update our string to basically remove all of this, and then we can start from right here. We can do this by reassigning copy input is equal to copy input dot substring, and this time we're going to start one past where this space was. The index of that space was here in our working index. So let's go ahead and take our working index, which is the index of the space, and increase it by 1. So this will get everything after this space. Now, we need to extract the ID from this string. Well, luckily, it starts from the beginning right here. So there's a few things that we can do. And it's going to be fairly similar because the ID will start from right here and ends right before that first space. So now we're going to reuse our working index, and we're going to call equals copy input dot index of this space. So this would get this index right here. Now using that, what we can do is extract string s model ID is equal to copy input dot substring starting from 0 to that working index, just like we did before. Now the issue is, this value is assumed to be an integer, but currently it's a string. If we were to create an int I model ID, then what we could int is the wrapper class to convert this string into an integer. So we call integer.parseInt s model ID. Now once we've extracted that, we update it again. So we recall copy input equals copy input dot substring from our working index plus 1, which that basically updates the string to only have these values left. Now we need to get our x position. And this works in a very similar way. Working index is equal to copy input dot index of the space. Then we extract it, string sx is equal to copy input dot substring 0 to our working index. Then we convert double dx is equal to double dot parse double SX. Then we update our input. Copy input equals copy input dot substring from the working index plus 1. Now we do the exact same thing for the y coordinate. And finally, we do something similar for the z coordinate. This time we don't have to worry about calculating that working index because this is the last part of the string. So now that we've extracted all these values, so now let's output all of this extracted information just slightly differently. And now let's run the program and see what happens. So we've prompted the user for this information. Let's go ahead and enter Ada, followed by 23, that's our model ID. And let's say its x coordinate was 2.2, y was 3.3, z was 4.4. Now once I press enter, as you can see here, it extracted all the information out and it formatted it with each one of these elements here. Notice that after located at, we have that escape character, that end line, which is why it jumps down to here. And then between each one of the coordinates, there's a tab which adds this many spaces in between. String operations can be difficult and they can be confusing, and for that reason, let's take a look at this example in more detail. Now, as you can see right here, this is what was entered into the console for the most part. We're only going to concern ourselves with the name, the model ID, and the x coordinate. Whenever it is called string input equals keyboard.nextLine, then the input is equal to this. From there, we made a copy of this input, that way we can work with it. Once we've called int working index and we called the method index of this space, what it does is it looks through this string until it finds this first space. And as you can see, the first index is index 3. Next, when I call copy input from substring starting at index 0 up until but not including 3, it extracts 0, 1, 2, or ADA, and assigns that to the value stored in name. Now, this copy input, I've already processed the name part of it. I don't need to worry about this anymore, so what I can do is call copy input starting from that working index. Remember, that was 3. 3 plus 1 is 4. So starting from index 4 all the way to the end, it extracts this. And then our copy input is just simply the model ID followed by that coordinate. This basic process continues until we've extracted all of the information from it. However, this is not the only way that we can approach this problem. Let's take a look at a different example of how to approach this. Now what we're going to do is we're going to create another new class because we're going to do this in a different way. And we're going to call this the player parser scanner and also include our main method. Now from here, we're going to write our name inside of a comment. After that, we need to import java.util.scanner. That way we can use the type scanner. Now we construct a new instance of this type scanner, tying it together with our console. Then we prompt the user once again for the same thing. Then we capture the input from the console, and the string is going to be formatted in the exact same way that we talked about before. Now the big difference here is we're not going to use string operations to do this, because we can recognize that scanner can not only just scan system.in, you can use it to scan strings as well. So now we're going to create another instance of type scanner. In this case, we're going to call it scanner, str scanner, a string scanner, is equal to new scanner. But we're not putting in system.in. We're not scanning that. We're scanning this. Let's scan our input. So now we're going to extract the name, the ID, the X, Y, and Z position. So string name. Now we're going to set this equal to the str scanner, and we need to capture everything up until the first space. Well, remembering back, I know there's a method called .next. And what this does is capture every character up until the first delimiter. So this separates the name out. Once I have that, I need the model ID. Int I model ID is equal to string scanner.next int. We just extract the next integer value, which should be the model's ID. Then double dx is equal to string scanner.next double. We know the next value has to be the x position, which is a double. Same thing for y. And same thing for z. Now we're just going to output it in the exact same way. Now, with this source code selected, we're going to run this, and we're going to do the exact same thing. Ada 23, 2.2, 3.3, and 4.4. And as you can see, it did the exact same thing, but we just did it in a different way. As programmers, we are using computers as a tool to solve problems. However, solutions to problems can come in many different forms. It's always about understanding what is your knowns and how we can map those to our unknowns. It is a really good practice to read through documentation, to read through how this programming language is used, and especially understand the various class types and the methods that you can use to make your life so much easier. And with all that being said, I'll see you next time.